Hi guys, and welcome back to another chemistry topic. We're going to be covering potential energy diagrams of exothermic and endothermic reactions. So to start off, on our y-axis we have potential energy, and on our x-axis we have a reaction coordinate. To start off, let's look at the exothermic reaction energy diagram. So if we look at number 1, we have our reactants. As we can see in our key over here, our reactants are just what's on the left side of the diagram. Then we have below number 2, which is the potential energy of the reactants. So it's just the stored energy of the reactants that's going to be used eventually for the reaction to happen. Then we have 3, the activation energy of the forward reaction. Basically what this means is it's the energy needed to start the chemical reaction in the forward direction. So it goes from left to right. So it's just the energy barrier that must be overcome in order for the reactant to transform into products. Moving on, we have number 4, our potential energy of activated complex, which is just stored energy of the activated complex, which is on number 5. But what is an activated complex? An activated complex is the maximum energy. It's a transition stage, but it's very quick and it's very unstable. It's where old bonds are breaking to form new bonds. Then we have number 6, which is our enthalpy, or our delta H. Enthalpy is basically the change in the amount of heat that is either released or absorbed in a reaction. So it can be either positive or negative. In this case, though, since we have our exothermic reaction, we are releasing heat, right? So as you can see in these arrows, it's going down, it's dipping. So it would be a negative enthalpy change, or negative delta H. Now for number 7, we have the potential energy of the products, which is just the stored energy of the products. Then we have number 8, which is the activation energy of reverse reaction. So instead of a forward reaction, we're going from left to right. In a reverse reaction, it's the energy needed to start the chemical reaction in the reverse direction. So we're going from right to left. But last but not least, number 9, where our products are, which are all the way on the right side of the diagram, and it's what's being produced. So overall, in this exothermic diagram, we can see that we have negative enthalpy. What this is showing is that the potential energy, as we can see on the y-axis, it's lower in the products than it is in the reactants. And once again, that's just because in an exothermic reaction, we're releasing that heat. So it's exiting the system. Similarly, in our endothermic diagram, all the labels are the same. The only difference is our enthalpy. So rather than stepping down, as we did in the exothermic, it's stepping up. So it's a positive enthalpy. Now what this is showing is that the potential energy in the products, which is all the way over here, is higher than the potential energy that was in the reactants. And once again, this is because in an endothermic reaction, we're absorbing heat. So our potential energy is going to be increasing because we're storing more heat, we're storing more energy within the products. So just to reiterate any words that you might still not understand fully, activated complex is just a transition point. It's the peak of the diagram where there's the maximum amount of energy, where old bonds are breaking to form new bonds, and it's very unstable and it's very quick. And then for the activation energy of a forward reaction, just think of going forward. So you're reading it from left to right. It's what you need in order to overcome the potential energy of the reactants and be able to form products. Then vice versa, the activation energy of the reverse reaction, it's the energy that you need to start the chemical reaction in the reverse direction. So you're going from right to left, from the products to the reactants. And last but not least, The enthalpy change is different depending on if it's an exothermic reaction or an endothermic reaction. So you have to always remember that an exothermic, it's releasing heat, so we're actually losing potential energy. That's why it's lower in the products. And then an endothermic, you're absorbing energy, so that's why it's higher in the products.